Hey, Russ here. Welcome back to the shop. I want to talk about a portable power unit. I'm working on my big main portable power unit, and when I get that done, I'll show that to you. I'm actually just doing all the necessary stuff to make it all come together properly rather than a prototype, and I'm trying to clean it up and make it a finished product. When I get that done, I'll go over all the details about it with you and show you why I built that the way I did. So basically, that unit is based on 12-volt larger acid-filled batteries, and that's what it's based on. And I could take the battery out of my car and out of my riding more, throw it in there, and I have instant portable power. And when I'm done using the portable power, I can take those two batteries and put them back where I got them and go back to using them and put this on a shelf. And I don't have to worry about it having a shelf life because the battery pack is the part that goes bad on those things anyway. And I'm actually double duty my batteries so that at least I have some portable power if my power goes down. Anyway, with that in mind, the other type of portable power you want is maybe you don't want 100 amps hours or more. You know, all you want is something simple that you can carry, plug in, run your camera or run your phone or run your laptop. You want to be able to run all the small stuff and be able to carry them very portable. You can buy those. They're called portable power stations, and those usually you can plug into 12 volt or you can plug it into 110, or you can even hook up on a lot of them. You can hook them up to a solar collector and charge the battery pack up with that. The price on those things is based on how much power those things put out, which is to say it's based on how much battery it has in that unit. If you only have 240 watts of power in the battery capacity, that portable power station will run you probably around $300, give or take a little. And it goes up fast from there. You can go to a 400 watt, and it's like $150 more. So really fast, you can go from 240 watts to 400 watts, and it's $150 more. So what I'm going to do is I'm going to make my own portable power station, small power pack unit. And I'm going to base it, believe it or not, on the Ryobi 18-volt lithium battery. These things, this is the 5 amp hour battery. It's the biggest one they make now, I think. But they're always making a bigger one, so it won't be long. They'll make them even bigger. But the 5 is probably enough to get me going. That converts to right at 90 watt hours of power. The 12 volt, the cheapest one you can buy out there, those are 240 watt hours. So if I had 4 of these, I already have more power than even that does. It's getting closer to the $500, $450 unit by having 4 of these batteries. I use these batteries all the time in my workshop. But if I need a quick portable power unit, I just grab 4 of these and I'll be able to put them into my power unit, plug them in, and I'll have instant power, 360 watts of power by having 4 of them. If I only need 2, if I only need half that amount of power for what I'm going to be doing, I could actually just put 2 into my power unit and then go on down the road. So the amount of power that I get out of that portable power unit will be based on how many of these I can put into my unit, and I can put these in on the fly. Now, there are a couple of things that you have to overcome. All these power stations, they're all based on 12 volts. The inverter, the DC to AC inverter, that is based on a 12 volt system. So 18 volts is too much to run the AC inverter. You have a 12 volt car cigarette lighter plug-in. Also the 5 volt USB ports, they run based off of a 12 volt system. Now you can buy 24 volt pieces instead, but they're a lot more money, I've found. The 12 volt seems to be the most versatile pricing range for all that equipment. I could get all those pieces I need for an 18 volt system, but that just seems like that would be very expensive for the inverter, I guarantee it. So instead of $20 or $40 for a 400 watt inverter, you're going to spend a couple of $100 or more to go to 18 volts instead. So rather than do that, all I'm going to do with these is I have to figure out how to step it down from 18 volts to 12 volts. And then all my equipment can be based on 12 volts without any problem. And that's easily enough done with what they call a step-down buck converter. It has an adjustment on it. I can put anywhere from 3 to 40 volts on the input side of voltage. These two wires here hook up to any battery, and that will go in here up to 40 volts. On the output, you adjust the screw on it, and you adjust the output voltage anywhere from 3 volts up to 40 volts again. So I can set this, which is what I did, is I set this to 12.9 volts with this, and I never have to adjust it again. Now when I hook this up to my Ryobi, I'll be getting 12 volts coming out of my inverter, my converter. And that makes it pretty simple to be able to do that. Then I can build all my other equipment based on a 12-volt system. And I still am using my 18-volt batteries to do it. The other thing I had to overcome is how to easily hook these up so I can use them. If you know Ryobi, they have their own receptacle to fit these batteries. And they fit good. There's no problem. They always work. I've never seen one fail. The trouble is, this part, the plug-in, they're not available anywhere that I could find. I don't want to cut a dozen of these apart and have to be able to use these. So I had to find some way to be able to hook up the positive and negative battery to this. And the way I'm going to do that is I made an 1.25 inch piece of PVC pipe, heated it up with my heat gun, and I shoved it down on there and let it cool off. And that gave me my basic shape here for a connector. Now before I forget, I guess I did forget to tell you, I did see a guy out there that actually makes these using a 3D printer. And that was pretty cool. And I thought about that. The problem is, you can't buy those anywhere. You can make them with a 3D printer and you can get his file and do it, but I don't own a 3D printer. I don't have an interest to have a 3D printer. Honestly, I don't think I know anybody other than George that has a 3D printer. So that would be limiting. Not only for me, it also would limit you if you have the same problem, which I suspect you probably, most of you would. You don't have 3D printer access either. So I decided I had to do this using common materials. So that's why I went to the 1/4 inch PVC. I saw a guy do that on YouTube, and I thought, I can make that work for me. Now, mine's a little different than his, but the basic shape of the holding piece is just a piece of 1/4 inch PVC, 1.25 inches PVC pipe, schedule 40, and I just heat it up, put it on there, let it cool off, and now it goes on there. Now, these are rigid batteries, and I was surprised when I saw this, but this thing fits on there really kind of snug. And taking it off takes a little effort. Whereas on here, so I put a screw on the back here that I can just thread it right through there with threads on the plastic. And I use this and tighten it down on the back, and now it's on there. And I smashed it in right here with a little bit of heat on the PVC to bring this closer to my positive and negative contact points. So I just take the wire from there, and I just put a standard female connector on there, and I can take this now, and this one's the negative because it's black, so it would go here. Let me hook up the positive first. So I put the positive in there, I put the negative in here, and then I snug this down. Now I got a good connection. This will work. And it's easy. It only takes me a minute or so to put a battery in here and get it hooked up. It's not a snap-in use. It's not dummy-proof, but it is dummy-proof. You're not going to get these wires mixed up. How do I know it's dummy-proof? Because I'm the only one that's going to do this. This is for me. And I know positive and I know negative and duh. So it's idiot-proof as far as I'm concerned. You can make this and make it so you have blind plugins and do all those things. I kind of went the shortcut way. Anyway, this is the other thing I have overcome. So now I have my step down here, and I hooked up a little gauge to it at on the output, so that I can read out what I got. And as you can see, I'm getting 12.9 volts off of this battery. So if I gang all these together, 4 of these, I'll have 18 volts. And I will have 4 times 90, I'll have 360 watt hours of power. That should be plenty for small voltage stuff that I would want to do, like cameras and laptops and phones and things like that. It's going to be awesome. And it'll be very small because the whole base should be around 12 inches wide one way, 7 inches the other, and about 7 or 8 inches tall. I put a nice little handle on it. This thing ain't going to be much bigger than a lunchbox. And it shouldn't weigh more than 10 pounds. So this will make a great little portable power station that runs off of my already batteries that I use every day. And when I'm not using it as a portable power unit, take the batteries out, bring them back in the shop, put them back in use here, and set this thing up on the shelf. If I need it, I can get it down 2 minutes, have the batteries put in it, and I'm ready to go as a power unit. So that's the goal. I want to do it. I'm basing it on my 18-volt Ryobi battery, and I'll show you when I get done how this thing works. Now, I've already going to tell you, I probably shouldn't tell you this, because probably somebody out there is probably going to beat me to it then. But let me tell you what I'm thinking about doing from this. Now that I know I can make this portable power unit, and the hardest part I have is adapting all these batteries to it, right? So, but I can make up a 4-battery unit pretty easily, up to 4 batteries. I could run that thing off of 1 battery if I really wanted to. I only have to plug 1 battery in, but that only gives me 90 watt hours of power. So I can actually put up anywhere from 1 to 4 batteries in there to use it as a portable power unit. As far as charging them, the only way I can charge them, quite honestly, is from my battery charger. So I don't have quite all the capabilities that one of those units do. Recharging them, I would just have to take the battery out, plug them in, charge them up, and put them back in here if I wanted to continue to use this. So if I'm using this in FOGS mode, FOG, F-O-G-S, Forced Off-Grid Survival, if I go into that mode and I want to take my Ryobis and use them here and I have to replenish them, then I can recharge all these batteries while I run my generator and then use them again for my power pack for hours upon end. With 360 watt hours, I should, depending on what I put to draw on it, I should be able to run this thing for many hours without it going completely dead. So once I get done. And I figure that besides the batteries, the amount of money I'm going to have in this thing is probably going to be less than $50, but maybe slightly over. We'll see. When I get done, I'll let you know. And I'll let you know what components I used and why I used those to get all the features out of this that I do want. So, yeah, I could go out and buy one for $250. The problem is that for years on end, that thing would just sit up on the shelf, and probably the next time I want to use it, I pull it off the shelf, unplug it, and I find out that my battery pack is bad. Now I don't even have one. Whereas I'll be using these every day. Therefore, when one goes bad, I know it long before I have to depend on it for a portable power. So these will be a much more sustainable system when I need it. And my batteries will always be in good condition to be able to be put in here. So I think it's actually better than any power station unit out there that I'm aware of, because those do really have a shelf life because of the battery pack. You don't know when that's going to go. So I think I have better control over what happens if with this kind of system. And if I get one battery go bad, I can still run this off of 3 batteries if I had to. That's the beauty of it. So there's a lot of advantages to making your own battery pack portable power station versus buying one out there. That's where I'm at. I kind of wanted to show you where I was going with my new unit and let you know that when I get that done, I will show it to you. I think you'll like the features of that one too, just like you'll like the features of this. And I hope I didn't ramble on too much. I try not to, but that's not easy. So, but anyway, if you have any questions about this or suggestions, leave them in the comments. Believe me, I think this is something that it's very complicated and I don't have all the answers yet. I'm still learning this as we go along, too, about portable power units. I had no idea what we were getting into to start with, and I've already changed my idea. I really like this portable power station capability of using Ryobi batteries. That, I think, is going to be very cool when I get done. In fact, I probably shouldn't tell you this, but I actually, if you look at the power station out there that is Ryobi sells now, it's the supercharger they call it. You can put up to 6 batteries in it at one time to charge. Go look at the picture of that. Sorry about that. Just too good. Anyway, with that, the units, you plug your batteries in from 3 on each side, and it's like the size of a bread box with the batteries on the side with a handle on the top. And it does have a USB plug-in, so you can also charge USB items with the same charger. And I got to looking at that, and I'm thinking, why can't I make my own portable power station based on the same thing I did here with Ryobi batteries? Build a small box that's the size of the footprint of that unit, so it would set down on the table, and then that unit would set down on it, and you would plug it in so that all those batteries, when they're plugged in there, but you're not plugged into the wall, you can actually turn that into a portable power station by adding that secondary unit. All the batteries are there. They should hopefully be, and when you don't need it as a power unit, you have to charge it up. You can just take the whole thing over and plug it into the wall and charge all those batteries up, unplug it, take it, and use it as a portable power station, all in the same unit without any problem. And if you need 1 or 2 batteries for other things, you can take it out, use those batteries separately, and you still have your portable power unit with just slightly less battery power backing it up. It makes it very flexible, and I think that actually is going to be pretty cool, and I'm going to do that. So I'm going to buy one of those superchargers, and I'm going to hack it. I hate to do that. We're talking about, I think those things run about $90, but I think that will actually be a very fun project once I get around to that. So stay tuned. That one is coming soon. This one, hopefully, is coming along pretty good. And you see some of the ideas of how I've overcoming some of the problems in order to make this work as any other portable power unit. And it's going to be much more powerful. There she goes. You know who is trying to call me. Anyway, I do want to thank you for stopping by. If you have any questions here, just leave them in the comments. If you like this video, or if you learned something here, hit that like button. It tells me I'm going the right way. Most importantly, though, please come back again, because I'm nowhere near done. I better go see what you know who wants. But in any case, we'll see you again very soon.